In this video, we're going to talk about solving quadratics again, this time with factoring. Remember to solve a quadratic by factoring, you just factor it, and then set the factors equal to 0, and those are your solutions. This will involve some complex solutions as well, since we're in Algebra 2 now. So, remember factoring depends on how many terms you have. With 4 terms, we did grouping methods, so we grouped the first 2 and the last 2 together and then factored out a GCF from both, and so on. With 3 terms, we did rainbow method, and then you might need to divide or slide. And we're going to focus today on 2 terms. 2 terms in the past, you were looking for the difference of squares. So it has to be a difference, it has to be subtraction. And you were looking for 2 perfect squares, things you can square root evenly. So 4x squared, that square roots evenly, and 9, that square roots evenly. It's not -9, where the negative has to be there for it to be the difference of squares. It's just can 9 square root. So all you have to do to factor this is basically square root this thing. The square root of 4x squared is 2x. And the square root of 9 is 3. So this goes in the front of both of your factors. This goes in the back of both of your factors. And then you make one plus and you make one minus. Doesn't matter which. And that's it. Because if I do 2x times 2x, I get 4x squared. If I do 2x times -3, I get -6x. And this would be positive 6x, so those cancel out. And then 3 times -3 is -9. So it gets me back to where I started. So let's try a few more. Again, I just factored it. I haven't actually solved it yet, just for the record. If I wanted to solve it, I would set these 2 factors equal to 0 and solve. All right, on this one, the square root of 81x to the 4th is 9x squared. The square root of y squared is y. Make one plus, make one minus, that's it. Here, I can't actually square root 5 or 320, but there's a GCF of 5. When I take out that 5 from both terms, what's 320 divided by 5? 64. Now I can actually do the difference of 2 squares and just leave the 5 in front. So leave the 5 in my 2 factors. Square root of x squared is x. Square root of 64 is 8. Make one plus, make one minus. Same thing here. This one also has a GCF of 2. And then you could split x squared minus 4 into x plus 2, x minus 2. This one, you can see these get pretty fast. This one would be 7x plus 2 and 7x minus 2. What about this one though? This one we can't do the difference of 2 squares because of the plus. So maybe you think, well, maybe I'll just make them both positive. Maybe I'll do x plus 8 and x plus 8. And that doesn't work because you do get x squared and you do get 64, but you end up with an extra 8x and 8x. You end up with 16x in the middle. So that doesn't work. But if we have plus and minus, then we have to have a negative here in the middle. So what do? How can we factor this? In the past, I've told you it was prime, it's not factorable. And that's true if we stick only to real numbers. But since we're going into the world of imaginary numbers now, or complex numbers, you can factor the sum of 2 squares. You just have to put some i's in there. So it's what you would expect. It's still x plus 8, x minus 8. But if I want to get a plus here, all you have to do is put i's on the end of both factors. Let me show you why this works. So x times x is x squared. Then I get -8i times x and positive 8i times x, so the middle still cancels out. And then I do 8i times negative 8i, which is negative 64i squared. So these cancel, and that leaves me with x squared minus 64i, but remember I squared is actually negative 1, because I is the square root of negative 1, so if you square it, it becomes just plain old negative 1. So if I replace that I squared with negative 1, this becomes x squared plus 64. And that's how you get the plus there. So if it's ever the sum of two perfect squares, you factor it the same way as before with the difference of two squares, but again, just put i's on the end. So like this one would be 2x plus 5 and 2x minus 5, but just put i's after the 5. On this one, the square root of x to the 4th is x squared. Square root of 9 is 3. Make one plus, make one minus, and since it was a plus, not a difference, I'll put i's on the end. Finally, the square root of 9x to the 10th would be 3x to the 5th. Square root of 21 is 11. Make one plus, make one minus, and put i's because it was the sum of two squares. So that's the idea. So not too different. And remember, if you want to actually get from these to the solutions, you just set them equal to 0. So for example, let's take this first one. If I want to get where this like equals 0, then you just set both of them equal to 0. So do x plus 8i equals 0 and x minus 8i equals 0, which is just going to be negative 8i for one of your solutions and positive 8i for the other solution. So there you go.